Can light therapy really help athletes recover faster? In this video, we are looking at a meta-analysis titled The Effect of Photobiomodulation Therapy on Muscle Performance in Volleyball and Football Players. It was published in Sports Health by Chu and colleagues. The focus is photobiomodulation therapy, or PBMT. This is a non-invasive light-based strategy that has been studied as a way to support muscle performance, reduce fatigue, and improve recovery. Before we continue, make sure to subscribe to Sports Science Insight. Here we break down sports science research into simple, practical, and evidence-based insights for athletes, coaches, and practitioners. Now, let's see what the evidence says. Fatigue is not just a feeling. In sports, fatigue changes performance. Football players repeatedly sprint, accelerate, decelerate, and change direction. Volleyball players perform repeated jumps, explosive attacks, blocks, and fast movements near the net. When fatigue increases, performance can drop. Movement quality may decline, recovery becomes slower, and the athlete may be less prepared for the next training session or match. That is why recovery strategies matter. The faster athletes recover, the better they can perform again. The question is, can PBMT help with that? PBMT stands for photobiomodulation therapy. It is also known as low-level laser therapy or LED therapy. The important point is this: PBMT is not heat therapy. It is based on light-driven biological stimulation. The idea is that red or near-infrared light interacts with muscle tissue and may influence cellular energy processes. One proposed mechanism is improved mitochondrial function. That matters because mitochondria are deeply involved in ATP production. And ATP is essential for muscle work, recovery, and repeated high-intensity efforts. So, in theory, PBMT may help the muscle manage fatigue and recover after demanding exercise. But theory is not enough. We need to look at the trials. This article was not a single experiment. It was a meta-analysis. The authors searched scientific databases and identified 2,250 articles. After screening and eligibility assessment, 14 randomized controlled trials were included. These studies focused on football and volleyball athletes. That is important because randomized controlled trials are stronger than simple observational reports. But we also need to be careful. A meta-analysis is only as strong as the studies included in it. So the next question is not only, what did they find? It is also, how consistent were the studies? The included studies involved 124 football players and 70 volleyball players. All participants were professional athletes. But the PBMT protocols were not identical. The wavelength ranged from 630 to 940 nanometers. The energy dose varied widely. The timing before exercise also varied. And the application sites were different, including the legs and arms, depending on the sport and the exercise task. This matters a lot, because when protocols vary, it becomes harder to say that one universal PBMT method works for every athlete. So the practical message here is simple. PBMT protocols varied widely across studies. That means dosing, timing, wavelength, and application site may all influence the outcome. The first outcome was maximal strength. More specifically, maximal voluntary contraction, or MVC. The pooled results showed that MVC increased on average in the PBMT group. But the effect was not statistically significant, so we should not say that PBMT clearly improves maximal strength in these athletes. This is important for coaches. If your goal is to increase maximal force output, the evidence here is not strong enough to make a clear claim. There may be a positive trend, but based on this meta-analysis, PBMT did not clearly improve maximal voluntary contraction. So, for strength, the message is cautious. Possible trend, but no clear significant gain. The second outcome was muscle endurance. Here, the result was more interesting. PBMT significantly increased the number of repetitions. This suggests that athletes may be able to perform more work before reaching fatigue. The effect appeared stronger in volleyball players. That makes sense when we consider the demands of volleyball. Repeated jumps, repeated upper limb actions, and repeated explosive efforts can make fatigue resistance very important. In this meta-analysis, the clearest performance benefit appeared in fatigue resistance. So if we ask where PBMT looked most useful for performance, the answer is not maximal strength. It is endurance against fatigue. More repetitions before fatigue may be the key practical outcome. The third outcome was creatine kinase, or CK. CK is commonly used as a blood marker related to muscle damage after exercise. In this meta-analysis, PBMT significantly reduced CK levels after exercise. This suggests less post-exercise muscle damage or better recovery response. The effect was stronger in football players. That may be related to the physical demands of football, including sprinting, accelerations, decelerations, and large lower limb muscle involvement. So, for footballers, PBMT mainly help the recovery marker. But we should be careful with interpretation. Lower CK does not automatically mean better performance in every situation. It suggests a recovery-related effect, and it should be interpreted together with performance outcomes, athlete perception, training load, and context. This is where the interpretation becomes very important. The results are promising, but they are not final. There were only 14 randomized trials. Some studies had small samples. The protocols were different. The exercise tests were different. The doses, wavelengths, timing, and application sites varied. And the quality of evidence was not equally strong across outcomes. The evidence was rated high for MVC, but for repetitions and CK, the evidence quality was low. So even though the results for fatigue resistance and CK were positive, we should not treat them as a universal prescription. A positive result is not the same as a universal protocol. PBMT may help, but coaches and practitioners still need evidence-based dosing and sport-specific decision-making. So, what should we take from this study? First, PBMT may help delay fatigue. Second, PBMT may reduce CK levels after exercise. Third, the effects may differ by sport. In this review, volleyball players seem to benefit more in repetitions. Football players seem to benefit more in CK reduction. Fourth, protocol matters. Dose, wavelength, timing, treatment site, and exercise type can all influence the result. So the bottom line is this: light therapy may support recovery, but coaches need evidence-based dosing. PBMT should not be treated as magic. It should be treated as a possible recovery tool, used with good monitoring, good programming, and good scientific judgment. If this video helped you, leave a like, subscribe to Sports Science Insight, and stay tuned for more evidence-based content on training, recovery, and performance. And tell me in the comments, would you use PBMT with athletes, or do you think the evidence is still too early? See you in the next breakdown.